All right, everyone, we're going to go ahead and get things started here today. If I could ask for the next slide, please. Jeff, sorry about that. There you are. Awesome. All right, thank you again, everyone, for joining us. Today's webinar is part of the Green Tech Renewables training series, and we are very excited to be hosting today's webinar with our partner, Generac. Generac is a long-established leader in backup power and has expanded to provide a leading product offering of solar, energy storage, and whole home energy solutions. While Generac offers a very robust DC-coupled architecture, their products can also be integrated in an AC-coupled architecture, which is the topic of today's webinar. Next slide, please. But before kicking things off, just some very quick housekeeping. Product sheets and additional information are accessible through GoToWebinar in the handouts section. We will have a Q&A portion toward the end of today's event. To participate, please submit your questions through the GoToWebinar questions section, and a recording will be sent to all registrants. Next slide, please. To quickly introduce Green Tech Renewables, we are the nation's leading solar equipment distributor with over 80 locations nationwide. We carry the leading solar, electrical, energy storage, and EV charging brands to support your installation business. Prior to September 1st, you knew us as CED Green Tech. We have rebranded to Green Tech Renewables to emphasize our focused commitment to leadership in the renewables industry. We continue to operate as a division of CED, affording us unique scale and stability as we support our customers in a rapidly growing and changing industry. Please visit our website at greentechrenewables.com to view a map of all of our locations and to get in touch with a location near you. With our numerous stocking locations nationwide, our fleet of trucks rolling daily, our commitment to our values of service, integrity, and reliability, and an unmatched service offering, there is no better partner in solar than Green Tech Renewables. Next slide, please. And Jeff, with that, I'm very pleased to turn the mic over to you. Thanks very much for joining us today.
Awesome, thank you, Tom. Hey everyone, as mentioned, my name is Jeff McAndrew. I'm Director of Sales here at Generac. For those of you who don't know, I come to Generac through the Pika Energy acquisition years ago. I likely know some of, if not many of you who are attending today's webinar. Thank you again for the time today. We'll likely keep this under 30 minutes. We'll be pretty efficient here. We could take time for the Q&A. Tom, a huge thanks to our friends at Green Tech Renewables for hosting us, folks. They've been a tremendous partner to us for years. And honestly, a tremendous partner for our active installers as well. What I really want to cover today is why you should consider Generac for AC coupling. You all know what AC coupling is. I'm not going to spend much time on that or too many overly technical details. What I really want you to take away from this is why should you even consider Generac as your AC coupled go-to option. We'll touch on a few promotions that we have running. We will talk about how to actually couple or AC couple PowerCell, and then we'll have, as I mentioned, some time for Q&A. So as you all likely know, and as Tom alluded to, PowerCell is inherently a DC coupled platform. We have our own optimizers, rapid shutdown devices, and we love the concept of charging batteries with optimized DC solar power and really only inverting that power one time, which is great for maximizing efficiency in markets where you cycle batteries frequently, like Hawaii, California. Gives us the ability to load follow when the grid is down. If the sun's out, you may not tap into your battery at all in an outage when the sun's out. This functionality is inherent in most DC coupled systems, but the reality is there's a huge market of existing PV arrays that don't have batteries. The vast majority of them, in fact, as you all know. And now those homeowners are eligible for a 30% or may be eligible for a 30% tax credit on energy storage. So we absolutely needed to have both DC and AC coupled solutions in our arsenal. It's been an ask from installers for years. It's something I've probably been promising like half of you on this call for years, and it's a drum we've been beating for a while. One of the great things is that we built out AC coupling really with just firmware. We already had an inverter and batteries, et cetera, right? We've already got switches. So we just modified firmware to allow us to control a third-party PV system when the grid is down. So you're actually using the same components that some of you may be familiar with, minus our optimizers and rapid shutdown devices. And then commissioning is plug and play, and frankly, should only take a few minutes, if that. So there are a few other AC coupled batteries out there, and frankly, more coming. Here's honestly why I think you should consider AC coupling with PowerCell. First and foremost, from a corporate perspective, backup power is what we do at Generac. From homes to construction sites, hospitals, campsites, power plants, cell towers, you name it, we are probably backing it up in some way. We even recently moved into offering hydrogen fueled generators, which is a total game changer for the industry, and hopefully shows you all our commitment to continue to transition to offering more renewable solutions. But in terms of energy storage, we have a ton of expertise building and supporting backup power systems. From a technology perspective, our M6, frankly, that's our flagship battery. That's when you're stacking 6 battery modules in our battery cabinet. That offers 18 kilowatt hours with that 9 kilowatts max continuous power, 9 kW max continuous. So it's extremely powerful when you need it to be. And the capacity sits at a place that'll get most homeowners through the night in an outage. Installers love being able to install a single battery cabinet with 18 kilowatt hours versus 2 of most of all of, frankly, our real competitors' batteries, right? Instead of needing 2 charge 10s and 2 Tesla Powerwalls, we get a lot of contractors who are selling one 18 kilowatt hour battery, and that's sufficing because it's a more powerful option. And in my opinion, that power and capacity combined with our power manager is really what differentiates us from a technology perspective. For those of you who don't know, the power manager is our newest load control device. We launched this in the middle of the spring. So with this device, you'll connect up to 6 240 volt circuits from the main panel into the device, and it'll automatically manage those loads in the priority that you've assigned in the event of an outage. And technically it's 12 120 volt relays, but rated for 60 amps. But the reality is you don't necessarily need to manage, in most cases, you don't need to manage 120 volt loads. You really need to manage 240 volt loads. They're the ones that consume the most power. And so the key thing to understand is that we're automatically managing those loads in an outage. Yes, homeowners have the ability to turn loads on and off from the mobile app. And again, this the Power Manager's app interface is built right into PowerView, which is already the homeowner's app for PowerCell. So yes, homeowners have the ability to turn loads on and off from the app, but if everything's programmed well from the install, it should be a hands-off experience for the homeowner. We'll turn the well pump off if it's pulling too much power, and then we'll turn it back on when that power is available. And the way this works is you basically assign loads up to 6 in priority of 1 to 6. And if the system is ever overwhelmed with consumption in an outage or exceeds what we can output from the battery, which again is 9 kW, we'll automatically turn those loads off and then reconnect them in priority that you've assigned. So we'll keep the rest of the house running and we'll manage these 6 loads. You'll also be able to see what each of these loads is consuming. We have current transducers built into the system. So if you have 6 2-pole breakers pulled into the Power Manager, you're going to be able to see what each of them individually is consuming. And so if you notice that your hot tub is consuming 3 kW and the storm is just getting started, you can shut off that load right from the app. But the idea is that this would all happen automatically. And you can also set loads to automatically lock out upon an outage. And so the hot tub realistically probably falls into that category. This device, in my opinion, gives us a huge advantage over our competition in the functionality that it offers, as well as the ease of installation. So the problem with really all backup systems is that if you don't have load management, and this is true for generators as well, if you don't have load management and a system is overwhelmed with consumption in the house, the whole house loses power, assuming you're doing a whole house install. And that's going to drive a call to you, the installer, from a disappointed homeowner whose system didn't back up the house in an outage. It's probably one of the worst calls that you can get. Again, we're going to give the homeowner a better customer experience by managing those loads for them and preventing one of these overload events. It's also obviously a benefit to homeowners who aren't home when the outage hits, is they can turn loads off from their phone and extend the life of their battery for the things that they need backup, that they really need to back up the most, like a well pump or heat in the winter. I'll also say that this device MSRP is $9.99, so it's extremely cost effective. It installs in about 2 hours. You're talking about, I mean, compare that to installing some of our competitors' panels, like smart panels, that actually require, in many cases, a whole service panel upgrade. And even then, you know, those multi-$1,000 devices that take an electrician like a day to install are not automatically managing loads. So it's a cost-effective device, it installs quickly, and frankly, it does more to the loads that it's connected to than any of our leading competitors. Beyond the tech specs, we've got a super reliable supply outlook, and we've got stock at Green Tech locations now. Even if they have older stock at some locations, the reality is it's a firmware update. You can update firmware when you're on site. You can get the inverter internet connected in your shop. We can update firmware that'll have this functionality. Regarding pricing, we're going to be super cost competitive. I would say very cost competitive with Enphase and others when you're comparing apples to apples systems. I'll encourage you to work with your Green Tech Renewables location to look at an AC coupled bill of materials and review that pricing with them and your market development manager so that you can see apples to apples Generac versus whatever it is that you're using today for AC coupling. From a cost competitiveness perspective, it definitely helps that we're running a few promotions. The first of which, for those of you who haven't installed PowerCell before, is an ongoing promotion that we call the welcome offer. This basically gives installers $1,000 cash after they register their first install. It's super easy to do. Just go to generac.com/PowerCell/welcome offer, fill out the details on your first project. Once it's registered, we'll cut you a check for $1,000. In addition to that, through the end of the year, we're running what we call the buy 5, get 1 promo. Essentially, we've discounted all of our battery modules through Green Tech via SPAs to make it such that the 6th battery module is essentially free. So really, we've reduced the cost of each battery module by a 1/6, and that's huge. That's, you know, roughly $1,800 in value to you, the installer. It puts us in an extremely competitive spot from a price perspective. I'd urge you to work with your locations, again, your market development manager, to get updated pricing, look at comparisons. I think you'll find that we can literally back up more of the home for less money and give the homeowners a better customer experience from a backup power perspective. So moving into a slightly more technical conversation, let's take a look at what's required from a hardware perspective. As mentioned earlier, the AC coupling functionality is enabled by a firmware push to our existing XVT inverters. And beyond that, you'll need a fully loaded M6 PowerCell battery, so 6 battery modules in a cabinet, and a properly sized PowerCell ATS. Usually, at least in the mainland US, you're looking at the 200 amp service rated transfer switch. And then the appropriate load management devices. You could use SMMs, frankly. We urge our installers to use the Power Manager because it's so cost effective and it brings so much additional value to the sale. You're likely noticing, for those of you who've installed PowerCell before, this is pretty much the same bill of materials as a typical PowerCell system, with the exception of the PV links and snaps. And just note that you do need the transfer switch in order to do AC coupling. So from a configuration perspective, here are all of those components. You can see the battery, the inverter, the transfer switch, as well as the Power Manager. So in order for us to turn on and off the third-party PV when the grid is down, we need it interconnected on the load side of the transfer switch. That way, when the grid goes down, our inverter is going to simulate the grid, and the third-party PV inverter will turn back on, thinking that the grid has basically come back. But really, it's just our inverter creating a clean sine wave. So those of you familiar with the PowerCell inverter, you'll notice that the 50 amp protected loads output is hitting the E terminals on the ATS, and then the 32 amp output is connected on the load side of the transfer switch as well. And you'll also see the power manager here. Again, the way this device is installed is you're essentially mounting it below or near the main service panel, and then extending circuits from the main panel into the power manager's relays. There are 12 single-phase relays, so where you're mostly going to be connecting 2-pole breakers or two-phase loads, you'll run those conductors per breaker into 2 relays and then back into their breaker in the main service panel. It's incredibly easy install, and again, it just adds so much functionality to homeowners. The thing I want to be clear about is the power manager, you're backing up all of the loads that are connected in the main service panel in addition to the loads in the power manager. We've had some installers think maybe they're just backing up the loads in the power manager, or they're using it without an ATS in some configurations. No, you're backing up the entire main service panel and the loads in the power manager, but we're going to manage the loads that are connected to the power manager. So from a commissioning perspective, this probably looks like a lot on the screen. The reality is at my inverter, I could do all of this in like 3 to 4 minutes. It's quite fast. So it's very similar to commissioning a standard power cell system. It's only going to take a few minutes. You're going to apply power to the inverter, turn on your DC disconnects inside the inverter, turn on your protected loads breaker in the inverter, and then you're going to enable your inverter at the screen on the inverter, which will bring up the DC bus to 380 volts. Basically, it's going to take your AC voltage, it's going to really like rectify it, turn it into 380 volts DC. And then you're going to go to the inverter mod settings and adjust number of transfer switches to 1, which indicates that you have 1 transfer switch on site, which will be true if you're AC coupling. And then you'll change ENA load shed, which stands for enable load shedding from 0 to 1. This is telling the inverter that you have a power manager and we should do our load shedding sequences in a grid outage. And then you'll adjust a set point called AC PV power, and you're going to set this to match the amount of AC PV that's interconnected on the load side of the ATS. This needs to be, for our system, this needs to be 7.6 kilowatts AC or less on the load side. If you have like 12 kilowatts of microinverters, you can interconnect up to 7.6 kilowatts AC of them on the load side of the ATS, and the rest on the line side, export it right out to the meter. So then before you click out, make sure you save all of the settings on the inverter at the bottom of the screen. We've definitely had calls into tech support from folks who thought there was an equipment issue, but the reality is they just hadn't saved their settings, which is a pretty easy one to fix. Then if you need to turn on zero import, which will prevent the battery from grid charging, which may be required by your utility. We've seen this from some utilities. Then you go into the beacon installer tool on your phone or laptop. Those instructions are in the manual. Just takes another minute, and you'll be able to turn on zero import as needed. Again, just make sure you save any settings. From there, your inverter is all set, programmed, ready to go. You're going to enable your battery. This is a good time to go into the battery settings and adjust the min state of charge reserve, which comes stock at 30%. That means your battery will discharge down to 30% if you're using self-supply for time of use, like in California, or if you're participating in a virtual power plant program like we see in places like Mass, Connecticut, Rhode Island, Arizona, California. And then lastly, you're going to select your operating mode, which will either be priority backup, it'll likely be priority backup, or it's going to be self-supply. Confirm that you have internet connectivity. You should be good to go. Absolutely recommend that the last thing you do before you leave is just test islanding, shut off power to the house, make sure the transfer switch flips, which would be an indication that all your settings are good. You should see the battery supplying power to the house. I would wait a few minutes, at least 5 minutes, to see in certain circumstances you may be able to, we may be able to frequency shift on the PV array while you're there. It kind of depends on the battery state of charge and how much load there is in the house, but definitely test islanding, make sure that we're turning on the PV array after a few minutes. And when I say that, I mean we as in the power cell inverter is triggering the third-party PV array to turn on. And then that starts to power the house while simultaneously charging the battery. And then you can go ahead and turn power back onto the house and basically have shown your homeowner that the system is operating the way that you would expect it to. Again, all this commissioning, it kind of sounds like a lot when you walk through individual steps, but it's really It's just a few steps, and it can be done at the inverter screen very, very quickly. So you might be wondering what systems we're going to be compatible with. That's valid. The power cell should be able to AC couple with most UL 1741 listed interactive inverters, which is going to be most of the inverters that have been installed over the past few years. So as long as the trip thresholds haven't been modified from within the above, you should be good. So if you're in a place where you frequently do modify grid connection set points, like we do see installs that are, you know, at the end of the utility line, the installer has adjusted set points so that the system connects to the grid. We've definitely seen that with other inverters. Just make sure that if that is the case, they're within our trip threshold range, but it should be pretty standard. I don't think you're going to run into a lot of areas where we're not compatible with the inverter installed. One notable limitation to this feature is that we're unable to use it in conjunction with load management devices under Hawaii grid profiles. So really only in Hawaii, you're not going to AC couple and have a power manager, but in any other market, that's not going to be an issue for us. But for any of our folks who are on here from Hawaii, hello, and just be aware of that. All right, so as a follow-up to this presentation, you're going to receive a bunch of materials. We've got a spec sheet for AC coupling here. We've got a product overview video as well as a quick hitting video for you on how to check and see if a system has the most up-to-date firmware, and if not, how to get the most up-to-date firmware. We have a specific tech support line that is literally just the firmware update line, so that you're not calling into the same tech support number. You're literally calling a firmware update line. We also have a web-based firmware update request form. So as always, we got single line diagrams and a couple application notes walking through the details of these new features. And then finally, we've got pieces like social media and email templates so that you can promote this exciting news in your territory to your customer lists. Awesome. Again, thank you all so much for your time. I would love to take a look at any questions that have come through, and I will respond to those here in just a second. We've got a number of great questions here. Give me just 1 second. I'm going to open up my screen a little bit so that I can see these, just a little bit better. Okay, are appliance damaged if they're suddenly shut down via the power manager? That's an awesome question. Honestly, I think it depends on the device. You are definitely going to want to be aware of what appliances are and are not okay just having a motor like shut off hard. Built into the power manager, I should have mentioned this as well. Built into the power manager, we have relays for air conditioning, and so instead of hard shutting off an air conditioner's motor power to the AC, we could actually trip the thermostat to essentially say, hey, stop cooling or heating the house, which is for sure relevant. That's a really great question. There's a question around any issues with transfer switches. There was a small batch of transfer switches where we needed to update a fuse in the inverter to make sure that we never had an issue flipping over the ATS. That has been resolved. And if you have any questions about that, please don't hesitate to reach out to myself following the presentation. But yes, 100% that's been resolved. We've got a question in here about, does the manager seamlessly switch between solar battery charging and generator service? Okay, when we are AC coupling for now, just because really the core focus of this presentation was AC coupling, but this is a great question for anyone who is interested in gen integration, which is also a functionality that we've enabled through through AC coupling. The question is, does the manager seamlessly switch between solar battery charging and generator service? When we are DC coupled, yes, you will automatically switch. If we could power the house in gen integration, if we could power the house from solar and energy storage when we're DC coupled, we'll power the house from solar, then we'll kick in the battery if we need to. If the solar and the battery cannot cover the load of the house, or if the battery hits too low state of a charge, the generator will automatically kick on, take over the load in the house, and recharge the battery simultaneously. And that is seamless. I have that set up at my own house, and I've seen it. When we're AC coupling, we're not yet, we have not tested for generator integration yet when we're AC coupling. So just stay on the lookout for that. But when we're DC coupling, absolutely 100%, it's a seamless switch between solar, battery charging, and gen. Someone had just asked, are snappers required, and if so, when? When you're AC coupling, no, absolutely not. When you're AC coupling, you're literally just taking advantage of, you know, the SolarEdge inverter that's already on site, the Enphase micros that are already on site, potentially the SMA Fronius, whatever setup is already there, you're essentially leveraging that. And so if there's already micros on the site, or already optimizers on the site, or already some other rapid shutdown device, then you don't need to touch that. You don't need to be, I should say, you don't need to leverage our rapid shutdown devices if a third-party system is installed. And so, I mean, one of the benefits of AC coupling for our contractors who are super comfortable with Enphase or SolarEdge or any other inverter products is that you can continue to lay glass and continue to like run your operation as normal from a rooftop power perspective. And you can look at just using Generac for the battery backup, time of use, and daily cycling aspect. Like you can keep running your rooftop operation the same way that you have been, and just leverage Generac for the energy storage portion. Again, we're going to be sending out a ton of materials after this presentation. If anyone is interested in this slide deck specifically, I'll be sending a follow-up as well. Just reply back to me that you're looking for the slide deck. What I'd also like to do is get anyone and everyone who's interested in more information connected with the market development managers as well as your local green techs, so that we can usher you through this together. Do you have to max the cabinet with 6 modules, or can you do less? This is an awesome question. For right now, we're asking that you max the cabinet with 6 battery modules. I'm not, I would say that I don't know that that's always going to be the case. But for now, we're asking that installers max out the battery cabinet until we do a little bit more testing on 3, 4, and 5 battery module configurations. So again, just stay tuned for that information. We get a question about we do a lot of SolarEdge. Can we DC couple? You would AC couple our system to the SolarEdge equipment. That being said, I would prefer, you know, if you're looking at new installs as opposed to the retrofit AC coupled market, I would love to talk to you about DC coupling with PowerCell, leveraging our rapid shutdown devices and optimizers as opposed to working with one of our competitors. We get a question, how do you interconnect when a SolarEdge system is existing? I'll just, because we have just a little bit of time, I'll just go back and pull this up on the screen. Again, you're just going to, there we go. You're just going to interconnect, as long as it's no more than 7.6 kW AC, you're going to interconnect the SolarEdge and make sure the SolarEdge is interconnected on the load side of our transfer switch. And then that will allow us to, in an outage, push power out our 50 amp protected loads output to the E terminals and simulate the grid. And then after about 5 minutes, which is the utility requirement, 300 seconds, that SolarEdge inverter should see us as the grid, and that would trigger that inverter to turn on. So yes, we can, I have seen these systems AC coupled to SolarEdge. How many amps was the power manager? Okay. I want to maybe clarify here. So the power manager has 12 single pole relays, okay? If you have a 2-pole load, like a dryer, for example, you're gonna take up 2 of those relays. Each one of those relays is rated for 60 amps. So if you have a load on a 60 amp breaker, you could pull that through the power. You could pull, obviously, anything on a 60 amp breaker is gonna be a 2-pole load. So you're gonna pull both wires into the power manager and then back into the breaker. But each circuit in the power manager is rated for 60 amps. But the power manager itself, I like to clarify, because the power manager itself has nothing to do with how much power the actual inverter and battery cabinet can push. This battery cabinet, without any PV available, which are the specs that we advertise, is able to push up to a 50 amp surge and 9 kW max continuous. If you have PV available and we could push battery power and PV to supply the house, obviously we could push a lot more power, just like our competitors can. If we have an existing Enphase system, what components are required? Again, this was, you might have joined just after we showed this slide, but you're just gonna have our inverter, the XVT inverter, fully loaded battery cabinet, 200 amp transfer switch, and a power manager. And again, we can walk you through how you're gonna use those components to interconnect to an existing system. A good question. So the hot tub's usually 50 amps plus, so could you use it to manage it? Yeah, here's the thing about hot tubs. I can't speak for all hot tubs, but a lot of hot tubs are on a 50 amp breaker in the main, but then they go back to a sub panel that has like a 30 amp breaker for the electric heater and then a 20 amp breaker for the jets, or vice versa. And so yes, you could manage the 50 amp breaker that the hot tub is going into. The reality is, look, you gotta, if you're concerned about like length of protection in an outage, I'm probably gonna sign the hot tub up to be one of those devices in the power manager that is going to be locked out as opposed to manage. Something else I should mention, folks, is that you can use the power manager to manage, again, up to 6 240 volt loads. You can use Generac's smart management modules to individually lock out any additional loads. The reality is, from what we've seen, most homes don't have more than 6 2-pole breakers in the main panel. Now that could be changing as homes are becoming more and more electrified with, heat pumps, electric heat pumps for heat and AC, EV chargers, etc. In that case, if you have like 8 240 volt loads and you want to manage 4 of them, then I'd manage 4 of them through the power manager, lock out 2 in the power manager, and then use 2 of Generac's smart management modules to lock out the rest. Do you have 400 amp solutions DC coupled with Gen integration? I would ask that you send me a separate email. I don't want to get like too science project-y in this presentation during this time, but we have definitely seen our fair share of 400 amp panels with 2 200 amp split mains that we can work with. Can you use existing ATS that are not power cell? Okay, you might be referencing Gen integration here. As long as it's a Generac transfer switch, then and for Gen integration, it needs to be the evolution. It needs to have an evolution controller, which is most of our gens for the past few years. We would just want to update the control board in the generator, the Generac ATS, so that it's compatible with PowerCell for Gen integration. So technically, yes, if you're asking about generator integration, you can use a Generac transfer switch that is not specifically the PowerCell ATS, but what I'm going to do is just get you a control board that that essentially turns a non-PowerCell ATS into a PowerCell ATS. It's a really good question. There's a question around, so this only does critical load backup, not whole house. No, actually what I'm showing is the configuration where we're doing whole house disconnect. That might be a reference to being able to push 9 kW max continuous and a 50 amp peak. what I would say is it depends on the house. Like we have tons and tons of houses where we're doing managed whole home backup power. I'm not going to promise you that you're always going to be able to run every load in every house, and certainly not all at the same time. But when we reference whole home backup, folks, we're really saying managed whole home backup. Look, I have a 24 kW generator, and I still have load management at my house to make sure that that system doesn't overload, and I have a fully electric house. So, so yeah, we're doing managed whole home backup here. This is not what I would consider like a protected loads backup, because we're giving you access to most of, if not all of, these loads in the house, and that it's up to you to, as the installer, to prioritize which ones are being managed and locking out the ones that can't be backed up. For anyone who's looking to switch to Generac specifically and is wondering how you can get all the training necessary, we have an online certification platform for technical training. What we would want to do is, we're not just going to say, hey, go do this link and good luck. Definitely go through the certification training, but we're also going to want to schedule time with the market development managers, who are mostly quite technical, as well as our sales apps engineers, inside sales team, so that we can get to know you, work with you, and help you as you onboard from a competitor's platform to Generac. My email is Jeffrey, Jeffrey, .McAndrew, McAndrew, @generac.com. Tom, hopefully you can share that in the follow-up as well for any folks who want quick, direct communication on anything that we've covered today, because I can connect folks to market development managers, same day, if not today, then tomorrow. We get another question here about asking if the power manager is a critical load subpanel. I just want to be totally clear about this. The power manager is not a critical load subpanel. You're extending circuits into the power manager that you want to manage, and then they're feeding back into the main panel. So when the grid goes down, we're pushing power through the ATS. We're going to hit everything in the main panel. Power manager is just the loads that we want to manage. We're going to send power through the entire main service panel. The power manager is just going to turn certain loads that are connected on and off, or automatically lock them out. There's a question here around, is the power manager involved in and essentially like tricking the third-party PV inverter to allow it to keep supplying power to charge the batteries? That actually doesn't have anything to do with the power manager. That has everything to do with our inverter. The power manager is more so a recommendation to stay within code and providing the homeowner a better customer experience by managing loads automatically. But the reality is, grid goes down, our inverter is creating a sine wave and sending power to the main service panel from the battery. And that sine wave is what is essentially tricking a third-party PV inverter to think that the grid is present and to turn back on. And then that power will power the house and recharge the Generac battery. But really, it's the magic from the inverter, not the power manager. The power manager is really just a load management device that is not specific to AC coupling. Even when we're DC coupling, we highly recommend that you use the power manager. Whew, somebody's hitting my core here. How can Penn State compete with Ohio State this week? And I know that's coming from an Ohio State grad. Hopefully not too many of you are laughing at that. We expect Penn State's going to win this weekend. Last question, will you be sending a recording to our emails? I believe we are going to send a recording of this webinar out so that you all can review it. Again, that was the last question. My name is Jeff McAndrew. Tom, Green Tech Renewable team, thank you so much for hosting us. This was awesome. Really, really good questions and customer engagement. Thank you all. You'll be hearing from us soon.
Thank you very much, Jeff. Thanks to the team. Thanks, Nick, for your Penn State question, and everyone else for your wonderful engagement on this important webinar. Thank you, Jeff.
Hey, thank you, Tom. Take care, everybody.